My name is Mike, and as stated before, I'm going to be talking about the artistic misuse of digital information, otherwise known as databending. What is databending? Databending is a term inspired by circuit bending, which is the practice of taking hardware, typically things like keyboards or speak and spells, and short-circuiting them deliberately to create new, unpredictable sounds. It's used a lot in experimental music. It's used a lot in various performance. The concept here with databending is to take data and use it in unexpected ways to produce unexpected results. This data can be an image, a video, audio, could just be straight up data. And why would we want to do something like this? You know, it seems kind of weird, but I think if you think about it from the perspective of art, it makes a lot of sense. This quote's fairly long, but a guy named Brian Eno, a musician that was a huge inspiration to me, really interesting guy, said in a book he wrote, or a diary he wrote, and I just want to kind of focus on the highlighted portion here. The distorted guitar sound is the sound of something too loud for the medium supposed to carry it. The blues singer with the cracked voice is the sound of an emotional cry too powerful for the throat that releases it. The excitement of grainy film, the bleached out black and white, is the excitement of witnessing events too momentous for the medium assigned to record them. All of those things were a product of intentionally misusing something. Without messing around with the amplifier when it first came out with the guitar, you wouldn't have punk rock or heavy metal or most of the music that you listen to today. And I think that this paradigm can be applied to digital things as well. So what are different kinds of data bending? Here's an example of something just to kind of give an idea of what I'm talking about. There are three broad categories that have been devised. There's an artist named Benjamin Berg that is kind of, there aren't a lot of people that do this, but he seems to be someone that put a lot of stuff on the internet talking about these different ideas. And he created three different categories. The first is incorrect editing, which is directly manipulating a file designed for one format in another. So most of the time when you're doing something like this, you're taking an image and you're opening it up in maybe a text editor or a hex editor. And you're directly manipulating the data as it's represented in binary or hexadecimal or whatever that editor you're using is displaying it as. It could just be gobbledygook. In the case of this image here, it was used an application called WordPad, which is I think that's a Microsoft product. Is that who's sponsoring today? I forget. You can open an image in WordPad, and then you can save it, and you don't have to do anything, and it just adds additional information when you save it, which is kind of interesting. But it produces these really weird effects, and this has become kind of an effect in and of itself called the WordPad effect. Another type of data bending you can do is reinterpretation, and this is similar to incorrect editing, but a little bit more abstract in that you are actually using a process designed for another format with an unintended format, right? So the best example I can think of is, and I'll display this later, taking an image and running it through audio effects, and actually producing the results of those transforms on an image. The example I have here, it's not exactly digital, but you could think of playing a building with a piano as a form of reinterpretation. David Byrne had an exhibit a few years ago here actually, and a number of other places where he would take a warehouse and a piano, attach a bunch of wires to the piano to different parts of the building, and allow people to just play the building, which seems kind of silly, but I think it's a really interesting thing to do. The last one I want to describe is forced errors. And this one's kind of hard to find examples of, but the idea is that you intentionally make errors happen in an application to produce a data bent effect. The best example of this I can think of is Missing No from Pokemon. Missing No from Pokemon requires a few different things to happen intentionally in order to create the glitch. And in creating the glitch, you create a variable. Well, let me explain the glitch. So you have to go to, I believe it's Viridian City, and then you talk to an old man, and you have him show you how to capture a Pokemon, even if you already know how. And after that, you fly to Cinnabar Island, And from Cinnabar Island, you go to the eastern shore of Cinnabar Island, and you swim around for a little while, and eventually you will run into a missing no. Missing no is particularly interesting because it has this unexpected behavior that was not created by the game, right? The programmers did not intend to have a missing no Pokemon, and it became one of the most popular Pokemon. I mean, it became a phenomenon. This is one of the most popular glitches of all time. And it was all because of people intentionally glitching out their game. I think that's really interesting and powerful and pretty cool. So those are the three broad categories. I want to dive in now to a form of reinterpretation utilizing audio effects on non-audio data. And the way you do this is taking advantage of the data at its raw binary form, because data is data. It doesn't really matter. As long as you're not validating the data, you can run these things on anything, right? And you normally do this, the way that people have done this in the past is using a program like Audacity, because Audacity doesn't really have any sort of validation. You can add anything in there and it will generate a waveform for that file. So you can stick an image in there and you'll get a pretty gnarly waveform that's it looks like a brick. I don't have an example to show, but you can imagine that it doesn't sound very good, but all of the effects that are in Audacity are usable on that. And you'll find that these effects actually will kind of recreate what you would expect them to recreate in the audio paradigm. It kind of shows this transmodality, which is really interesting. The issue with that is that it's destructive. You use a file once, it mutates it, so you have to make sure you have a backup. If you don't, you're going to be sad. It's also kind of tedious because you have to do it once, export the file, look at it, decide if you like it, and then do the entire process again. There are improvements. AudioShop is a command line interface tool that actually inspired this talk, which utilizes FFmpeg and SOCKS to do exactly what Audacity does, but from the command line. So you could write scripts to do this multiple times, you could run it in batch, but it still doesn't have kind of that real-time effect that I think is really interesting and would really make this very powerful for performance and all sorts of other things. And for that, that's where JavaScript comes in. This is my very crude diagram to try and explain this idea, but effectively, we can take advantage of the HTML5 canvas, the web audio API, and typed arrays to allow communication between these two APIs at the level of a buffer. So what we do is we take an image, we get image data, we take that image data and convert it into an audio buffer because we have the raw data, and with typed arrays we can create whatever type of array is needed for that input. And then we pass that audio buffer that we made from the web audio API into an offline audio context, which then allows us to apply a bunch of different effects using an audio graph. The way that the web audio API works is that it allows you to basically replicate a digital audio workstation in the browser. So you can add things like reverb, you can add panners, you can build really complex effects using different low-frequency oscillators and filters and things like that. And it will generate very quickly a new audio buffer, which once we've done that, we can convert using those typed arrays again back into image data, which we can then pass into the canvas. And then we'll have a rendered drawing of a databend image. And you can actually take this same idea and utilize it with video, because there's this really cool thing you can do with the canvas and video, in that if you pass to the canvas draw image function a video, it will draw a frame. It will just draw it. I don't know how it does it, but it does it, and it's really handy. And you can set sort of a fake frame rate of sorts to generate very quickly these frames, and in the time that it takes to render that, also run it through that data bending stuff. So I kind of want to, well, now I want to show you what that actually looks like, and I have a demo for it. Oh, let's see, how do we get that over? There we go. All right. So the first thing I want to do is show you guys an image. I'm going to take this fun image. This is the Pope getting hit by a meteor. Yeah. It's a sculpture from 2009. It's called La Nona Ora. And I'm noticing that I don't see what I normally see here. I think it's because maybe the, hang on one sec. There we go. That was weird. Okay, so up here, it's kind of hard to see unfortunately, but we have various effects and parameters that we can control. And these are all being powered through the WebAudio API. So what I can do here, I'll do a simple one right now. This is a gain node. This is basically going to make whatever signal you have louder or quieter depending on the value. If I activate that, and I increase this quite a bit, you will see that now the Pope is ready for MySpace. So that's just a simple one, but there are a lot of things we can do. So if you look at, let's see, how about a biquad filter? Biquad filters are really complicated ways of describing various types of frequency cutoff filters, so high-pass filters, low-pass filters, bandpass, etc. We can do things like make the image black and white. We can, because this is a time series, we have the ability to partially affect the filter, or partially affect the image with the filter. So I can do something like that, and I'm affecting less and less of the time series. These values are vaguely arbitrary at this point, but you can imagine that under the hood, I'm basically saying for a certain portion of this time series, this sample, which is an image, only run this effect for a certain period of time. There are different helpers that allow you to do this. It allows you to have things like envelope filters, ramping up of effects, ramping down of effects, things like that. We can also do, we can do multiple filters at once. So maybe I want to add a ping pong delay. That's kind of cool. Maybe I want to like shift it a little bit, add a little feedback. You can see these copies of the Pope to the left and right. They're kind of, let's see, if we turn the feedback up, you might see them better a little bit. Oh, that's too much feedback. That's the fun thing about this. You really don't know when things are going to break because everything you're doing is against a spec. The playback rate, this is fairly self-explanatory. It affects the rate of playback, right? So if I increase this, it's going to play a sample faster. Or in this case, I'm going to get, ooh, that's interesting. You're going to get double popes, but because I have other filters on, you can't really see it too well. There you go. Pope 1, Pope 2. So that's images. And now I want to kind of tie this over now to video. So I think video is really fun to look at. And for this, I don't know why I decided, but at the very beginning of this kind of journey, I decided that I wanted to just use the dancing baby as a test. You guys remember the dancing baby? I love the dancing baby. Yeah, it's good stuff. I also have this little audio sample that's playing. Let's see if it works. It doesn't work. That's because I guess the sound is not happening. That's all right. But let's just look at the video. So again, we can do those similar effects that we have. A bit crusher is a effect that normally will make something sound much more metallic and distorted. It reduces the quality overall, and I think it's kind of cool in the context of video and imagery because it does the same thing to a baby. Like it's a weird-looking baby. You can also change this parameter and put the baby in jail. You can also look at the dictionary, apparently. Poor baby. But he still dances. Or she, I'm not sure. Close that. Let's see, what else can we do? We can do pitch bend. This is pretty fun. So I'll do something not too crazy just to start. Yeah, that's nice. You can add a little bit more. You can actually see it starting to bend a little bit, the image itself. And this is measured in cents, so you could actually, if I want to go up 400 cents, which I believe is an octave. Oh, there's some sound. Interesting. Oh, interesting. Yeah, so you can hear in the background that audio that's playing. That is separate from this image. It has nothing to do with the image, but I wanted to kind of show the effect in something you were a little bit more familiar with. So because I've increased the pitch so much that I'm actually changing the note, I'm effectively making it happen faster. I'm increasing the rate of the entire sample, which is causing this to just look insane. But you can hear that, which hopefully is helpful. So we can take that off. We're back to the normal. Go back to bit crusher. You can hear that now. Baby's in jail. Baby's tough. Baby dances. Let's see, what else we got? The biquad filter. We can also apply a ton of different values for these effects at different points using a function called setValueAtTimeCurve, I think. And you pass it a float 32 array of different values, and it uses linear interpolation to automatically determine where in the sample it should have these different values happen so that it's evenly spaced, I believe. So if I have, oh, this is cutting the frequency quite a bit. Let's see. Actually, you know what? Maybe we just do the inverse. Let's do a low pass. That should be a little bit better. There we go. If we randomize that, yeah, that's pretty fun. So this is just a filter happening really, really fast. This is all happening with just like regular browser stuff, by the way. This is pretty awesome that you can do this in 2017. But it's fun. You can go down a little bit. Let's see. Let's go back to high pass. And if I can get it right. Let's see. Down a bit. I hope no one here is having like issues with, yeah, you can get this like wobble effect. That's pretty tight. I'm into that. So biquad's pretty cool. Let's see, what else? Going back to playback rate, I have to do this. It's probably annoying, but I really like it. If I randomize the playback rate. I love that. It's so much fun. Okay. You guys can imagine I'm just up to like 2 a.m. every night just doing this. My girlfriend is so sick of looking at the dancing baby. This might break, but I'm going to try it. This is a phaser. Phaser is a more complicated audio effect that takes advantage of lower level filters that are in the Web Audio API. I'm actually using an audio effects library to build a lot of these more complicated things because I didn't build them myself. It's called Tuna.js. If you're interested in this sort of stuff, you should definitely check it out. But the phaser, let's see, yeah, it works, cool. This actually looks really similar to, it does slow it down a bit. It looks a lot similar to what the, I think the spectrogram of a signal that's having a phaser applied to it looks like, this color. It's really nice. Kind of reminds me of like a save point in Final Fantasy. But yeah, and what happens though, and I'm going to see, yes! So this is a bug, but I think it's really cool. Because that takes so long to render, I get this built-up queue of like frames that have been processed with the offline audio context ready to be rendered, but they haven't yet, and they're just stuck. And so you get these like ghost frames, and it's really fun. If you're doing this for a while and you have like, let's see if this happens. I'm going to add phaser back. I'm going to break this. It's going to rule. Sometimes you get a maximum call size stack exceeded error, which means you're doing real JavaScript. Let's see. Yeah, I think I got it. Yeah, maximum call stack size. That's okay. You can just refresh. So let's go back here. All right. Go back with the baby. Play the sample again. Let's put on the ping pong. Look at those. Baby has friends. Put on a phaser. Baby and friends are phased. Add some wah-wah. I don't even know what this is going to do. At this point, I think everything is just stuck. So what I'm hoping is that when I undo some of these, yeah, that's good. Yeah, there's the Wawa coming way later. Let's see. It's pretty fun. What if we randomize the detune? Not. Yep. So you can imagine that maybe this isn't something you'll use in your day-to-day very much, but that's not the point. The point is that you're just exploring. You're just looking for weird stuff. And maybe you see something cool, and maybe you decide that you want to actually implement that correctly, or you want to figure out a way to implement that correctly. I don't know. That talk that just happened earlier, the Bauhaus and the browser talk, the way that those blending modes work and things like that, I feel like that is a result of people experimenting with how imagery is rendered, how videos are rendered, and seeing these glitches, think, man, those are cool. I really wish I could do that without having to break stuff. So I feel like this is kind of that first step to getting there. And it's really quite rewarding. Let me just turn the sample off, because it's probably kind of annoying. It didn't turn off. You gotta love bugs. You gotta love them. But it's okay, because we're going on a databender, right? So I'll just go back from here to the actual presentation. So yeah, like this obviously is just kind of fun. It's not really something you would ever do at work unless you worked at maybe like an agency. And it's not, you know, it's not necessarily something that is going to help you in your day-to-day. But I think there is a huge amount of reward for kind of saying, all right, I'm not going to do it right this time. I'm just going to explore and try things a little bit differently and be creative and not worry about getting that vision that you initially were told to produce. Get that speed curve, you know, that metric that you have set, whatever. You're not going to worry about that. You're just exploring and seeing what will happen. And from that, you might actually find some really cool stuff. Just from looking at that demo, you know, what are some things that we could potentially do starting from that as a foundation? We could try to bend streaming media, real-time media. This currently is impossible, as I believe you would need faster than real-time streaming. But there are people who are trying to make this happen, and I don't know a lot about it, but I hope it can happen, because I would love to be able to data bend a webcam source. Trying to integrate external APIs to trigger those different parameters. I was just using GUI and changing values, but you could imagine that perhaps some APIs returning random values, or not random values, but a different range of values, and those are influencing what's happening. Maybe some sort of draw effects. You know, since that's a time series and we can figure out in the time series where we are, we can in theory map that to a place, a representation, the pixel of the image, and actually click around and draw those effects. And you know, we have this web MIDI API that probably nobody really uses, but it allows you to connect a MIDI controller and control events in the browser. So if you actually did want to use this during a performance, you could set up your MIDI controller to handle events in the browser and potentially have all of your music playing in the same audio context, and you're just using Chrome to play a show. So I want to leave this with a quote that I really like. It kind of, I feel like, encapsulates the journey that I've taken in kind of working on this. Being someone who really enjoys just creatively coming up with strange stuff. I like doing that, and it's not something you get to do a lot in your day-to-day when you're following specs, reading documentation, getting tickets that have all of your acceptance criteria, hopefully. And I think when you're in that point of fastly approaching burnout, there is, you know, at the end of the day, this code, all of these things, we can do whatever we want with it. And sometimes it's fun to just say, screw it, I'm just going to break the rules and see if this idea I have works. And a lot of the times it won't, and that's because it wasn't designed that way, but sometimes it does. And from that, you get just so much joy. I don't know. I highly recommend everyone tries doing this sort of work at some point. If anybody wants to play with this demo, I've got it up on GitHub pages. You can ask me after if we can get the link down. I might not have pushed up the most recent version, so I'll do that right after. And so if it seems weird right now, that's why. And there are also some resources here. Tuna.js was the audio effects library I used to create that phaser, the wah-wah effect. Audio Shop was that command line interface tool I was talking about a little bit earlier that directly inspired this talk. The artist Benjamin Berg, who also goes by Saint Alio, I guess. I haven't actually heard it pronounced. That blog of his is particularly helpful for understanding kind of the motivation and philosophy behind this. And learning more about typed arrays, I found this article to be particularly helpful. It's just an HTML5 rocks article. Yeah, that's it. Thank you very much.
Thank you. That was awesome.
Fantastic.
So are there any limitations that have really bugged you right now?
Totally. Yeah, the biggest one is that you can't use a media source with the offline audio context. So you can't do webcam, you can't do real-time streaming, which makes sense, but it's frustrating. What else? Oh, you also, when you're using an audio node in the Web Audio API, you can't get from that node the current place in the track where it is. You have to calculate that yourself, which is really strange, I think. The Web Audio API is great, but it has just weird little issues that makes it not perfect.
Yeah, tell me about it.
Yeah.
Well, thank you so much for coming. We really appreciate you being here.